name is Juan Martinez Saenz, and I'm a senior at the University of Missouri studying electrical and computer engineering. The COVID-19 pandemic has affected the lives of so many people, and in particular, the pandemic has placed unusual stresses on employers looking to manage their indoor spaces responsibly. For example, at Mizzou's Recreational Center, the administration was forced to hire more employees responsible for the enforcement of new social distancing guidelines. This came at a time when memberships continued to drop as a result of the pandemic, producing an expensive and ineffective financial challenge for the administration. Using that example, my capstone group and I developed a project with the intention to help keep our fellow citizens safe, as well as a product that could be used by thousands of employers and building managers across the world facing a similar challenge. The system we developed is called the COVID-19 Social Distancing Reader, or the COVID-19 SDR for short.
My name is Kenyon Shutt, and I'm a senior at Mizzou studying electrical engineering. The COVID-19 SDR relies on computer vision, deep learning, and automation to help reduce the cost of keeping the occupants of a public space safe. It's comprised of several units which can be installed in various locations around a room. We developed a camera unit, a graphic user interface, 2 different kinds of visual indicators, a custom power supply, and a simulated door locking system. In addition to managing our team's engineering development process, I worked on the networking hardware and power system design.
My name is Zach Wanawawi, and I'm a senior at Mizzou studying computer engineering. I developed the computer vision unit, which acts as the core processing unit for the system. The graphics processor inside the unit runs the YOLO object detection algorithm. It's an open source, pre-trained, deep learning library for computer vision applications. The algorithm processes each frame, and with the results, number of detected people in the frame is counted, and their distance is calculated using the Euclidean formula. The counters storing these 2 pieces of data are then made available to the GUI when it requests the current occupancy of the room.
My name is Jillian Schulte, and I'm a senior at Mizzou studying electrical engineering. I developed the graphic user interface for the SDR. The GUI features a full-color touchscreen which allows the user to set up, control, and manage the system's parameters such as room capacity, camera height, door locking status, power system health, and more. After the user enters the correct PIN, they'll have access to control all of this information. The GUI also acts as the master unit for the network and handles the transfer of information as it flows around the system.
Hello, it's Juan again. I also developed the SDR's output devices. The 2 most visible units of the SDR are the 2 visual indicator units. The first unit, the bar indicator, is a clear and concise set of green, yellow, and red LEDs arranged in a stack. When it receives an occupancy percentage from the system, it presents it to the people outside the room. The more LEDs that light up, the closer the room is to capacity. Another unit I developed is a traffic light indicator, which is located inside the room. It has 2 larger lights, one that's red and one that's green. The state of these lights will change depending on whether the system detects that the room's occupants are 6 feet apart or more. If everyone is at a safe distance, the green light remains lit. If not, then the red light will turn on. Finally, I developed a system which simulates an electromagnetic door locking system. Again, if the room is at capacity, the red LED light will turn on, signifying that the room's door has been locked. The user can override this lock by pressing a button on the system or by temporarily disabling the lock on the GUI unit.
It's Kenyon again. Overall, our project was a success. Although the system hasn't yet seen its first permanent installation, we met nearly all of our goals as a prototype system. Although it works well, many developments must occur for the system to succeed as a real product. First of all, we need to increase reliability by vigorously testing and expanding upon the computer vision algorithm. We'd also like to include a method for which the data or the video could be recorded for later review. And finally, we'd really need to make the system easier to manufacture by improving the design of our circuit boards, enclosures, and cabling systems. Thank you for watching this presentation about our senior capstone project. If you'd like to get in touch with our team, you may find our information linked below. Thanks again, stay safe, and go Tigers!